right, so section 11.7 deals primarily with cones and specifically volume and surface area. So we've been dealing with volume for the past couple sections, and that's the cubic area inside a shape. Surface area is the two-dimensional, so the flat surface all the way around. So we measure that in in square, just like we would regular area. So first we have some equations. So the volume of a cone is just like the volume of a pyramid, where it is 1/3 the area of the base times the height. Now, in a cone, the base is always a circle. So essentially it is 1/3 pi r squared, which is the area of a circle, times h, where r is the radius of the circle and h is the height of the cone. So the volume is just like you do the base times the height, 1/3 of that. The surface area is a little bit different. It is the total area on the outside of a solid and you find surface area in general by adding each face together, and it will always be measured in square units. Just like any regular area. So if you come up with the idea of surface area of, say, a box, you are adding together the area of the top face, the front face, the top and the bottom, front and the back, the left and the right. So you're adding those pieces together. So to find the surface area of a cone, specifically we just do a right cone, so it's not tilted to the side or anything. We can only do ones that are right up and down. The two faces of this would be kind of the part that's going up and down and the bottom. So the surface area of a cone is the base face plus what we call the lateral side. And the base face is the circle on the bottom. The lateral side, if you actually were to unroll it, it would get this kind of Pac-Man-y shape. And that is, the base face is pi r squared, because it's a circle. And to find this Pac-Man shape, it is pi r L. And L is this slant. So where does that L come from? Where does that L come from? Well, if you did the area of a sector that you're looking for over the area of the circle equals the arc length over the circumference. So that's like in 11.1 and 11.2, we talked about setting up those ratios. So essentially, it's this sector area compared to what it would be as a whole. And then you can see 2 pi r is this length right here. So area of the sector over pi l squared equals 2 pi r over 2 pi l. So essentially it's comparing the two circles. I'm sorry if you can hear my dog barking in the background. multiply both sides by pi L squared. You get the area of that lateral side. Bruno. You get that area of the sector equals, well, the 2's cancel out, the pi's cancel out. One of the L's cancels out, and you're left with the pi r L. It is totally fine if you didn't follow that, but some people are just wondering why the pi r L comes out like that, and that's why. In any case, you're just doing the pi r squared and then the pi r L. So let's do some practice. Find the surface area of the cones. So surface area is pi r squared plus pi r L. So we need r and we need L. So r in this case is 4, L is that lateral area, that lateral side, 6, the slant. So I have pi 4 squared plus pi 4 6. And you can put that whole thing in your calculator and you get 125.66. So it's surface area, so it's area, so it's going to be square units, and it's going to be in inches. Try that again. We have the surface area is pi r squared plus pi r L. We need r and we need L. The only difference here is we do have r, but we don't have L. This is why it's important that this is a right cone, because we can use the Pythagorean theorem to find it. So 5 squared plus 12 squared should give us L squared. 25 plus 144, that's 169. So the slant is going to be 13. And then you can put that all in your calculator. Pi 5 squared plus pi times 5 times 13, and that'll give you 282.74. All right, and so go to part 2 for some more practice.